Okay, so this is another example for moment area diagram in solving for deflection. So the problem states that we need to determine the slopes at ends A and D. So slope here at this point also. And then the deflections at point B and point C of the beam. So the beam is simply supported by a hinge at A and a roller at point D. It has two concentrated loads, 270 and 180 at points B and C. Its EI is constant. E is 12.5 gigapascal and I is 1.92 times 10 to the power of 10 millimeters to the fourth. Okay, so first is we need to solve for the reactions at the supports. So we have RA and RD. Then we sum up moments at point T equal to 0 to solve for RA. Say assume clockwise positive. So RA times 12 minus 270 or equals 270 times 6 plus 180 times 3. So RA is equal to times 6 times 3 over 12, 180 kilonewton. Then summation of forces vertical or along Y, say upward positive, RD plus RA is equal to 270 plus 180. Cancel out 180, RD is equal to 270 kilonewtons upwards. Okay, so after getting the reactions at the support, we will now sketch the elastic curve of this beam due to these two loadings. So we can base our elastic curve sketch on the original loading of the beam. So we can see that this is a greater value. So under such load, we will assume that it has a deeper depth of deflection than this 180. So kung i-sketch na to na siya, see, this one. So this is our elastic curve. First is we sketch for tangent line. So tangent to the elastic curve at point D and tangent to the elastic curve at point A. So say that is tangent line at point D and then tangent at point A. Oops. So from the horizontal or the original position of the beam, this angle is theta A or the slope at A, and this one is the slope at D. To solve for theta A, we can use this triangle to solve for theta A, and then for theta D, the same. We can use this smaller triangle or this triangle or this triangle. So you can choose between those three kung sa imong gamiton to solve for theta D. Let's start with theta A. From the elastic curve, this is our elastic curve at point D to tangent line at point A. This is the deflection. See, this one is the deflection. This is the deflection of point D relative to point A. Then tangent of theta A is equal to the deflection of point D relative to A over this base. So this side opposite over adjacent side, which is equal to the length of the beam, equal to 12. Then tangent of theta A is very small daw na siya. Very small, that we can directly say that tangent of theta A is equal to theta A. So this equation becomes theta A equals deflection of D relative to A over 12. So this is now the equation in order for us to solve for theta A. Okay, so from the figure again, from the original position of the beam at B and at point B of the elastic curve, this distance is the deflection of point B. Same as with point C. So from its original position to its deflected shape, this is the deflection of point C. And then from point C of the elastic curve to the tangent line at point D, this distance is the deflection of point C relative to D. And this one, point B of the elastic curve to tangent line at point A, this is the deflection of B relative to tangent line A. So to solve for theta D, we can solve for theta D by using the two tangent lines at point A and at point D. So kana siya si tangent line at A and tangent line at B. This angle between the two tangents is the change in slope between point A and point B. So this angle is the change in slope of A and point D, or from point D to A, which is equal to A to D or D to A, the same. This is equal to this is equal to, as you can see from the figure, this angle is equivalent to this angle, so this is theta D, and then this angle is equivalent to this angle, or this is theta A, this one is theta B. So therefore the change in slope between point A and point D is equal to theta A plus theta D, or theta D is equal to theta dA, or change in slope from A to D, minus theta A. So after we get the value of theta A, we can then solve for theta D by using this formula. And then using the value of theta D, we can solve for the deflection at point C. So kaning nga triangle na pala to i-consider. So from that triangle, we can say that theta D is equal to opposite, which is theta C plus theta CD over this adjacent side, which is equal to 3 meters. So theta D is equal to delta C plus delta CD over 3, or delta C, or the deflection at point C, is equal to 3 theta d minus delta CD. So this is the equation to solve for the deflection at C. And then the last value that we need to solve is the deflection at B. We can use the value of theta A as can be seen in this triangle. So theta A is equal to delta B plus delta BA over 6 meters. So theta A is equal to delta BA over 6, or delta B is equal to 6 theta A minus delta BA. So we have now the solutions or equations to solve for theta A, theta D, or the slopes at A and D, and then the deflections at B and C. Now na to si theta A. Before maka-proceed in solving for the deflection is we need to sketch for the MEI diagram. So ato ni siya i-transfer. And then sketch for the MEI diagram under the sketch of the original beam. Okay, so based on the reactions and the loading, so reaction at A, so naman tayo RA dire, RA. Solving mo ang moment dire sa point B by cutting the beam at point B, analyzing the left section. Ang moment ano niya is counterclockwise. So this is moment at B. By using this part of the beam, MB is equal to RA times its distance. So M at B is equal to RA nga 180 times its perpendicular distance nga 6. 180 times 6 is equal to 1080 kilonewton meter. And then solving for the moment at this point, at point C, so i-cut ang beam, analyze the right section. Pag right section ay analyze, ang moment is clockwise. So moment at C is equal to, ang load niya dili kay RD ra, so RD times its distance. So moment at C is equal to RD nga 270 times distance nga 3. 270 times 3 is 810 kilonewton meter. So this is 1080 and then 810. And then we need to sketch the M over EI diagram. So kanina mga values, i-divide na to og EI, or the flexural rigidity of the beam. E times I. Okay, so na tayo MEI diagram. Let us solve first theta A. Theta A is delta dA over 12. Theta A is equal to delta D relative to A over 12. Delta D relative to A is equal to the integral x bar of M over EI diagram from A to D. So this is equal to the moment, so integral of the summation of all the moments from A to D. So area times its perpendicular distance Tapos, ang atong i-determine is D to A man. So, D on the elastic curve relative to tangent line A. So, the first subscript, na siya ang point kung aha imong kuhaan o deflection. So, diri ni maiparotate ang tanang areas. So, we have 4 areas. Kay ang atong MEI diagram kay composite yung shape. So natay first triangle, ano siya, first, second, third, fourth areas. Tapos diri din ang iyahang reference point kung aha na to i-rotate ang tanang areas. 1080 minus 810 to 70. So this one is 2 270 over EI. So let's start with the leftmost triangle, or ang triangle under MEI diagram from A to B. So 1/2 times base is 6, height is 1080 over EI, times its perpendicular distance, centroid padulong diri sa point D. So this is equal to 6 plus 1/3 of 6 plus the second area, ang area, just equal to 1/2. Base is 3, height is 270 over EI, 3 plus 2/3 of 3. And then the rectangle, plus 3 times 810 over EI times its perpendicular distance, 3 plus 1.5. And then the last area, 1/2, base is 3, height is 810 over EI times 2/3 of 3. Okay, so delta D relative to A is equal to 3.5, 6 times 1080, 6 plus 2 plus 1/2 times 3 times 270 times 3 plus 2, 5 plus 3 times. So addition siya tanan because the MEI diagram is above or na siya diri sa ibabaw sa ato ang beam. So na siya sa upper part sa beam. Pag na siya sa lower part, so i-deduct po na siya. 3 times 810 times 4.5, and then plus 0.5 times 3 times 810 times 2. So this is 41310 over EI, kilonewton meter cube. Therefore, theta A is equal to 41310 over 12 EI, or this is equal to 3442.5 over EI kilonewton meter squared. Or the value for the slope at A in radians. This is 3442.5. E is 12.5 GPa. 12.5 times 10 to the power of 6. 1 point exponent 10 divide 1.92 times 10 to the negative 2. 3442.5 12.5 exponent 6 times 1 point negative 2. This is equal to 0.014 radians. Or okay, so next is solve na to si theta d para magamit nato siya dayon in determining for delta C. So theta d is the change in slope. Theta d is theta dA or AD minus theta A. So isolve natin na siya ang change in slope. Change in slope from D to A or A to D is equal to the integral of M over EI from A to D, or the summation of all the areas under the MEI diagram from point A to point D. So kung tanaw na ito ang figure, kani siya tanan triangles, kani siya from A to D man siya tibuok. Okay, so this is equal to katong first na triangle, 1/2 base is 6, height is 1080 over EI. Second area is katong baliktad trapezoid, iusa ra nato siya. So this is 1080, this is 810, kanina base niya is 3. So the area is 1/2 base height over EI. Dayon plus katong gamay nga triangle nga 810 ang iyahang height, base niya is 3, so 1/2 3 810 over EI. So the change in slope between B to A is equal to 0.5 times 6 times plus 0.5 times 3 times 1080 plus 810 plus 1/2 times 3 times 810 is equal to over EI kilonewton meter squared. Dayon theta D is equal to 7290 over EI minus theta A. Si theta A is 3442.5. 3442.5 over EI, or theta D is equal to 729 minus 3442.5 3847.5 over EI. This is kilonewton meter squared. Theta D is equal to 3847.5, 12.5 times 10 to the power of 6, 1.92 times 10 to the negative 2. Theta D is equal to 3847.5 over 12.5 over 6 times 1.92 to the negative 2. 0.016 radians. Okay, so next na to solve is delta C. So delta C is 3 theta D minus delta CD. Okay, so delta CD is the deflection of point C relative to point D. So integral of m over EI dx from C to D. From the figure, C to D is kaning area. So kana ra nga triangle. Tapos ipa-rotate na to siya kaysa C na siya. Yung man nga distance from C to D. So pa-rotate na to siya about point C. So ang iyang perpendicular distance gikan diri sa centroid padulong sa point C. Okay, so area x bar. This is equal to 1/2, base is 3, height is 810 over EI times its perpendicular distance nga 1/3 of 3. So delta CD is equal to 1.5 times 3 times 810 times 1. 1215 over EI. This is kilonewton meter cube. Delta C therefore is equal to 3 times theta D is 3847.5 over EI. 3847.5 minus 1215. Delta C is equal to 3847.5 10 327.5 over EI. This is kilonewton meter cube. Tapos delta C, yung value na yun sa deflection is 10,327 over E nga 12.5 times 10 to the power of 6, 1.92 times 10 to the negative 2. Delta C is equal to 10,327.5 12.5 exponent 6, 1.92 into the negative 2, 0.043 meters, or this is equal to 43 millimeters downward. So na natin delta C, the last unknown na kailangan nato i-solve is kaya siya, si delta B, which is equal to 6 times theta A minus delta B relative to A. So ang kailangan nato is si delta B relative to A, which is equal to theta C. This is equal to integral of n over EI dx, or area times its perpendicular distance from point A to point B. Pero ang atong i-kuan is deflection sa B relative to tangent line A. So sa B ka mag-measure sa imong perpendicular distances sa imong areas. So A to B is kanira siya nga triangle. Or na siya nga triangle. Pero i-rotate mo about point B. So 1/3 of 6 ang iyang perpendicular distance. So area is equal to 1/2. Base is 6. Height is 1080 per EI. Perpendicular distance is 1/3 of 6. So delta BA is equal to 0.5 times 6 times 1080 times 2. 6480 over EI, kilonewton meter cube. So delta B therefore is equal to 6 times theta A, pila ito si theta A, 3442.5, 3442.5 over EI minus 6480 for EI. So this is equal to 6 times 3442.5 minus 686480, 14,175 over EI, kilonewton meter cube, or delta B is equal to 14,175 over 12.5 times 10 to the power of 6, 1.92 times 10 to the negative 2. Delta B in meters, 14,175 over 14,175 over 12.5, 1.92 to negative 2, 0.059 meters, or this is equal to 59 millimeters downward. So this is the deflection at B, deflection at B, deflection at C, slope at D, and then the slope at A, slope at A. So that's it for the first example.